Next, we have agriculture sector. So in agriculture, federated learning can help optimize crop yield prediction models by aggregating data from aggregated models developed from different data sources from various farms, preserving the privacy of individual farmers' data. So it preserves privacy of individual farmers' data. 7, we have energy management. Energy industry. So basically, energy consumption patterns vary across regions and user types, and FL can develop energy management models tailored to specific contexts while keeping energy usage data as private. So it can keep energy usage data as private while developing models like energy management, while developing energy management models are tailored to specific contexts, right? Eighth application, we have smart cities. And smart cities, again, smart city infrastructure uh, generates diverse data streams, and federated learning aids in creating models for traffic optimization, waste management, urban planning, and so on, again while preserving the data privacy. So smart cities can federated learning can develop models for traffic optimization, waste management, urban planning, and so on, while preserving privacy. Next application, we have retail industry. So retail chains with multiple outlets and can collaboratively enhance the demand forecasting and inventory management models while sharing sensitive sales data. So in retail industry, again, federated learning can be used. So to preserve sensitive sales data information, while training models to basically develop models for demand forecasting, inventory management models, and so etc. And finally, 10th application, we have environmental monitoring. So here the reason is the environmental monitoring involves collecting data from distributed sensors. Federated learning allows the development of accurate models for pollution prediction, climate analysis while preserving the data. So it helps in pollution prediction and climate analysis. while preserving data privacy. So we have discussed 10 different applications. There can be different other applications like defense sector, educational sector, and so on. So a federated learning is basically an interdisciplinary, now can be applied in any domain based upon the application and the task involved in that application while preserving the data privacy. Now let us try to understand the tasks that we can that are involved and the paradigms the federated learning has. So all the paradigms that we have discussed as part of in the previous parts, basically the zero shot learning, one shot learning, few shot learning, and so on, and the tasks that we discussed: classification, detection, segmentation, tracking, sequential tasks, generative AI, everything can be applied in federated learning, again while preserving the data privacy. Now let us look into some specific paradigms that are now well known research areas or within themselves. The first thing, we have federated zero shot learning. So basically, federated zero shot learning aims to extend the capability of zero shot learning to a federated setting. So in zero shot learning, a model can recognize classes it has never seen during training, and in a federated scenario, multiple clients hold distinct classes and collaborate to improve zero shot recognition across the clients. So that is the advantage of federated zero shot learning. Basically, it aims to extend the capability of zero shot learning to federated setting. So basically, in a federated learning scenario, as I said, multiple clients hold distinct classes of data and collaborate to improve the zero shot recognition across all clients. So mathematically, if we try to understand, let us consider a set of clients C as C1, C2, C3, and so on, Cn, with each client has its own set of classes. So each client has, let's say, y1 1 and so on, yl of 1, and c2 has y1 2 and so on, ym2 and so on, cn has y1n, so on, ykn. Right now, the goal is to train a global model, let's say global model GM, that can recognize the classes from unknown classes during inference. Let's say unknown classes that can be union of I is equal to 1, 1 to 1 to z. We have y. So the aim here is to recognize classes it has never seen during training. So now federated zero shot learning is used to leverage the diversity of classes present across clients, enabling the global model to generalize to a broader range of classes without sharing any raw data. So here the FL zero shot, federated zero shot learning is used to leverage the diversity of classes present across multiple client devices and enabling the global model to generalize to a broader range of unseen classes, and again without sharing any raw data. So that is the beauty of federated learning. It allows all the paradigms along with preserving the data privacy. So now federated zero-shot learning basically can be applied in applications, may be valuable in scenarios. It is valuable in scenarios like wildlife monitoring, where different clients, example, different wildlife reserves have distinct species data and aim to collectively identify a wide range of species. So it can be applied in application domain like wildlife monitoring, where clients here will be are basically different wildlife reserves and they have distinct species of data, species data, and aim to collectively identify a wide range of species, while again not sharing the raw data information. So that's pretty much about federated zero-shot learning.